All right, so get this. Today, we're diving deep into a world that, well, let's be honest, might not scream excitement at first glance. Software testing. But stick with us because I promise it's way more interesting than it might sound.
It really is.
We're talking about software that actually, does what it's supposed to do
Yeah.
and the difference that can make when it comes to, well, everything. Safety, money, even lives. You guys sent in a ton of material on this, and we're going to break it all down.
Yeah, it's amazing how many people think software testing is just about, like, squashing bugs, but it is so much more than that.
Right. Like, I'll admit, when I first saw this sack of research, I'm like,
Yeah,
oh
yeah.
boy, this is going to be a dry one. But then I started reading about some of the software disasters out there, and it was like, whoa, okay, this stuff really matters.
It really does. It's all about risk management,
Mhm.
making sure the software we use every day, all the time, actually does its job safely, efficiently, reliably.
So let's start with the basics. All of our sources seem to agree on like a general definition of what software testing is. It's about matching the software to expectations,
Mm,
making sure it's defect-free, identifying any gaps, errors, things like that, right?
exactly. And it's not just about finding those glitches, it's about figuring out why they're there
Hmm.
and how to stop them from happening again.
Ooh, and let's not forget the expensive part. I was reading about that Bloomberg terminal crash back in 2015. Remember that?
Oh, yeah.
300,000 traders affected. A government debt sale got delayed because of it. That's not just a minor inconvenience. That's
Yeah.
like a ripple effect with huge financial implications.
Absolutely. It shows how everything is connected.
Mhm.
One little software glitch can snowball,
Yeah.
disrupt markets, businesses, even whole economies.
Yeah, and it's not always just about money either. That Nissan car recall, over 1 million vehicles
Mm-hmm.
because of a software issue with the airbag sensors.
Right.
And then on top of that, there were actually accidents linked to that, which is scary.
Yeah. It is. It really underscores that software testing isn't just some abstract code thing. It's about real world consequences. People's safety, preventing serious harm.
Makes you think twice about those software updates, right?
Yeah.
But then, there were some almost funny examples in there too. Like, remember that time the Starbucks POS system crashed and everyone got free coffee?
Oh, yeah.
You
And so
know,
they couldn't process anything.
gotcha.
It was total chaos.
Right. It reminded me of that Amazon glitch where products were listed for like 1 penny. I bet some people got some crazy deals.
I'm sure they did.
But for the sellers, it must have been a nightmare.
Oh, absolutely. These examples, even the funny ones, they highlight how these little bugs can have massive ripple effects.
Right. Affecting businesses, finances, people's lives. So let's switch gears a bit and talk about the benefits of doing software testing well. Our research highlighted a bunch, but I think we should go beyond just, listing them. Let's really get into why they matter.
Definitely. Let's start with cost effectiveness. Finding those bugs early in development can save a ton of money later.
Oh, for sure.
It's way cheaper to fix a problem in design than, recall a million cars.
That's a good point. It's like, why wait for the whole building to collapse when you can just, fix a crack in the foundation? Catching bugs early isn't just about saving face, it's about saving some serious cash.
Exactly. And the savings go beyond fixing the bugs themselves, too. Good testing can cut down development time, minimize rework, prevent costly delays.
Our sources also talked about security in software testing, which, it makes sense, right? With data breaches happening all the time.
It's huge, yeah. Think about all the sensitive information we trust to software. Bank details, medical records, personal conversations, all of it. Software testing helps protect that data, make sure the systems we rely on are strong and secure.
So it's not just about, like, stopping hackers from stealing credit card numbers. It's about protecting our privacy, preventing identity theft, which can be devastating.
Absolutely, and it's bigger than individuals, too. Data breaches can cripple entire businesses, damage their reputations, erode consumer trust.
Okay, so we've got cost effectiveness, we've got security. What else does thorough testing do for us?
Well, it directly impacts the quality of the software itself. A well-tested product will be more reliable, more stable, perform better. It'll do what it's supposed to do consistently.
Which ultimately leads to a better user experience, right?
Oh, absolutely, and that's crucial for success.
Happy customers are more likely to stick around, tell their friends, and, contribute to the long-term success of a product.
Exactly.
One of our sources had this really formal definition from ANSI 1059. Basically says that software testing is all about evaluating the software, making sure there are no missing requirements or errors, and that it's secure, reliable, and performs well.
Yeah, it's a good way to summarize it. It's not just bug hunting. It's making sure the software does what it's meant to in a safe, reliable, and efficient way.
But here's where I start to get a little overwhelmed. Apparently, there are over 150 types of software testing.
I know, right? It can be a lot. But don't worry, you don't need to memorize them all. It's more important to understand the main categories. Think of it like a map. You don't need to know every street to get around a city. You just need to know the main roads.
Okay, that's a good way to put it. So what are the main roads of software testing, so to speak?
Well, you can break it down into three main categories: functional testing, non-functional testing, and maintenance testing.
Okay, so functional testing, that seems pretty straightforward. Does the software do what it's supposed to do?
Yeah, exactly. It's about checking that it functions according to its specifications. Like, if you have a button that's supposed to save a file, does clicking it actually save the file in the right place?
Okay, so simple but crucial. And what about non-functional testing? I think our source material also called it performance testing, right?
Right, yeah. This category is more about how well the software performs. Does it run smoothly? Can it handle lots of users at once? What happens if there's a sudden spike in traffic?
So it's not just about whether it works, but how well it works, especially under pressure.
Exactly.
Okay, and then we have maintenance testing, which it sounds like it's about making sure changes and updates don't break things that were already working.
Exactly. You don't want to fix one problem just to create a new one, right?
Yeah, it's like renovating a house. You might add a new room, but you don't want to cause a leak in the roof in the process.
Exactly.
So maintenance testing is about making sure those updates don't have any unintended consequences.
Exactly.
Okay, so we've got these three main categories, and within those, there are all these different testing strategies and techniques,
Right.
which maybe we can dive into later. But for now, I think we've laid a good foundation for what software testing is all about.
Yeah, I think so.
We've covered a lot. But before we move on to those testing strategies, maybe we take a closer look at some of those real-world consequences of software glitches. You know, the serious ones and the kind of funny ones. To really drive home the point that this stuff matters.
I think that's a great idea. A few memorable examples can really help people understand the impact of software testing, or the lack of it. So let's jump into some of those real-world examples, shall we? Remember that Ariane 5 rocket launch back in '97?
Oh yeah, didn't that thing like explode just after takeoff?
It did, and you know what? It all came down to a software conversion error. Basically, a number was too big for the variable it was being stored in, something that could have been easily caught with, proper testing.
Wow, so a tiny software bug took out a $370 million rocket. I'd say that's a pretty good reason to invest in good testing.
It really is, and it's not always just about the money either. Think about the Therac 25, that radiation therapy machine.
Oh, right.
Back in the '80s, software flaws in that machine led to patients getting massive overdoses of radiation.
Okay, that's pretty terrifying. It's easy to forget that software isn't just websites and apps. It's controlling really critical equipment,
Right.
stuff that has a direct impact on people's lives.
It does, and these high-stakes examples, they really highlight why we need rigorous testing, especially when software is being used in, safety-critical applications.
Okay, well, let's lighten things up a bit. What about some of those less dramatic software glitches, the ones that are more, I don't know, frustrating or embarrassing than life-threatening?
Yeah, those can be interesting too. Remember the Y2K bug?
Oh, yeah, good old Y2K.
Everyone thought computer systems would just collapse when the year changed to 2000.
I remember that. My parents were stocking up on canned goods like it was the apocalypse.
Right. It turned out to be a lot of hype, partly because of the huge effort that went into fixing those potential issues.
So even the fear of a software bug can have a massive impact. It shows you how much we rely on software working reliably on a global scale.
It does. It's a good reminder that software testing isn't just about fixing what's broken. It's about building confidence, preventing potential problems.
Speaking of confidence, one of our sources talked about how important testing is for building trust with users.
It is, absolutely. When software works the way it's supposed to, when it's reliable and secure, it builds trust between the user and the product.
But when it's buggy and unreliable, that trust is broken.
Yeah.
It's so frustrating when something doesn't work right,
It is.
and it makes you less likely to use that product or trust that company again.
Think about it from a business perspective. If your website crashes all the time or your app is full of glitches,
Yeah.
your customers are going to go somewhere else.
Right, it's like going to a restaurant and getting served a burnt meal.
Hmm.
You're probably not going back.
Exactly. In the world of software, quality matters. And software testing, that's the key to getting that quality and building that trust with your users.
Okay, so we've talked about why testing is so important, and we've seen some real-world examples. Now, Let's dive into those different types of testing. What each one actually means.
Sure. Where do you want to start?
Well, we've got those three main categories: functional, non-functional, and maintenance. But within those, there's this whole world of different approaches and techniques.
Yeah, and the specific types of testing you use, it'll depend on the software itself, what it's supposed to do, the risks involved.
So there's no one-size-fits-all approach. You have to tailor it to each project.
Exactly. Think of it like a toolbox. You wouldn't use a hammer to tighten a screw, right?
Right.
You use the right tool for the job.
Okay, so let's open up this toolbox of testing techniques. What are some of the ones our listeners should know about?
Let's start with unit testing. This is like the most basic kind of testing. You're testing individual components of the software in isolation.
So like making sure each ingredient in a recipe is good before you combine them.
That's a good analogy. You want to make sure each piece works on its own before you start putting them together.
Makes sense. And once you've got those pieces tested, you need to make sure they work together. That's where integration testing comes in, right?
Exactly. Integration testing focuses on the interfaces between different parts of the software, making sure data flows smoothly, the interactions are seamless.
So it's like making sure the engine, transmission, and wheels all work together to actually move the car.
Precisely. And this is often where you start finding those tricky bugs, the ones that pop up from how different parts of the software interact.
Okay. And once you've tested the individual parts and how they fit together, then you move on to system testing. That's where you look at the whole thing, right?
You got it. System testing is about evaluating the complete integrated system, making sure it meets the requirements, performs as expected in a real-world setting, like taking the car for a test drive.
Okay, so that's where you test things like performance, security, usability,
Exactly.
everything from a user's perspective.
It's like the final exam, making sure the software is ready to be released.
Now, one of our sources mentioned regression testing, which sounds kind of like going backwards. What's that all about?
Regression testing is about making sure that any new changes or updates to the software haven't introduced new bugs or broken existing functionality.
So you're making sure that fixing one problem didn't accidentally create another.
Exactly. It's like making sure that painting your living room didn't somehow cause a leak in the bathroom.
That's a good one.
Regression testing is essential for keeping the software stable as it evolves.
And with software constantly being updated, it sounds like regression testing is an ongoing thing.
It is, and it can be pretty time-consuming, which is why automation is becoming more and more important. But that's a topic for another time.
Okay, duly noted. Now, one type of testing that seems really important these days with everything being so fast-paced online is performance testing, right?
Absolutely. Performance testing is all about how well the software performs under different conditions.
So making sure a website doesn't crash when a lot of people are using it at the same time.
Exactly. It's about making sure it can handle real-world usage, that it's smooth and responsive for the user.
I bet that's super important for things like e-commerce websites, online gaming platforms.
Absolutely. Anything that involves a lot of users or data processing.
Okay, so we've talked about unit testing, integration testing, system testing, regression testing, performance testing. Are there any other big ones we should know about?
Well, one that's becoming more and more important, especially with all the data breaches and cyber attacks, is security testing.
Oh, right. Security testing, making sure the software is protected from unauthorized access, right? Keeping those hackers out.
Exactly. It's about finding vulnerabilities that could be exploited, like checking the locks on your doors and windows.
So it's all about protecting sensitive data, making sure the software can't be compromised.
Exactly. Security testing uses a bunch of different techniques, like penetration testing, where ethical hackers try to break into the system, and code analysis, where experts look for weaknesses in the code itself.
Sounds like a constant game of cat and mouse, with the good guys trying to stay one step ahead.
You could say that it's a challenge, but it's essential, especially as software gets more complex.
Okay, we've covered a lot of ground with these different types of testing. Clearly, there's more to it than just clicking around and seeing if things break.
Oh, absolutely. There's a real science to it. Strategic planning, careful execution, and a deep understanding of the software and the users.
Speaking of strategy, our sources also talked about different testing strategies, which seems like a whole other layer on top of the types of testing we just talked about.
Right. Think of it this way. The types of testing are like the ingredients in a cake. The testing strategy is the recipe, how you combine those ingredients to get the result you want.
Okay, I like that analogy. So what are some common testing strategies?
Well, one popular approach is black box testing. In this strategy, the testers don't actually know how the software works internally. They're just interacting with it through the user interface or API.
So it's like trying to figure out how a car works by just driving it, without ever looking under the hood.
Exactly. Black box testing is good for evaluating the software from a user's perspective, making sure it meets the requirements without needing to understand all the complex code.
And then there's white box testing, which sounds like the opposite, right? That's where you do look under the hood.
Exactly. White box testing is like having a mechanic's manual. You have access to the code, you can see how everything works. Testers can design tests that target very specific functions and modules.
So it's a more in-depth approach, requiring a deeper understanding of the software's guts.
It is. White box testing is often used by developers to test individual units of code. It can also be used to find security vulnerabilities or performance bottlenecks.
Okay, and then we have gray box testing, which I'm guessing is somewhere in between.
You got it. Gray box testing is a bit of a hybrid. Testers have some knowledge of how the software works internally. Maybe they know the general architecture, some key functions, but they don't have access to the whole code.
So it's like having a map of the city, but not knowing the layout of every building.
Yeah, that's a good way to put it. Gray box testing can be useful for finding integration issues or testing specific scenarios where some knowledge of the code is helpful.
So it's all about finding that sweet spot between knowing too much and not knowing enough.
Exactly. And the choice of which strategy to use, it really depends on the project itself, the software, the goals of the testing.
One of our sources mentioned program testing as a strategy. Is that a separate strategy or just a general term?
That's a good question. Program testing isn't so much a separate strategy. It's more of a core element of most testing approaches. It's the process of actually running the software, giving it specific inputs, and seeing what happens.
So it's the hands-on part where you're actually interacting with the software.
Exactly.
And it sounds like software testing isn't a one-time thing. It's an ongoing process.
You're absolutely right. It's something that happens throughout the whole software development lifecycle, from the initial design all the way through to deployment and maintenance.
It's like checking your work as you go along, instead of waiting till the end to see if it's all okay.
Exactly. Early detection and prevention, catching those bugs before they become big problems.
Right. And as the software changes and new features are added, the testing has to keep up.
It does.
One thing that stood out to me is that software testing isn't just about finding those bugs. It's also about making sure the software actually meets the needs of its users.
Absolutely. And that's where it gets really interesting, because it's not just about technical specifications anymore. It's about understanding how people actually use the software.
And what they expect from it.
Exactly. And that's where the idea of user-centric testing comes in.
Can you tell us more about that? What is user-centric testing and why is it so important?
User-centric testing is about putting the user at the center of everything. It's about understanding how real people will interact with the software, what their needs are, what kind of experience they expect.
So it's not just about making sure it works, but making sure it works well for the people using it.
Exactly. And this is where things like usability testing and accessibility testing become really important.
Can you give us some examples of how those types of testing work?
Sure, usability testing involves observing real users as they interact with the software. You take notes on any difficulties they encounter, gather feedback on their overall experience.
So it's like watching someone try to put together IKEA furniture without the instructions and seeing where they get stuck.
That's a great analogy. By watching people use the software, you can see where it's confusing, frustrating, or just not intuitive.
And then accessibility testing is about making sure everyone can use the software, right? Including people with disabilities.
Exactly. This includes people with visual impairments, hearing impairments, mobility impairments. Accessibility testing ensures that everyone can navigate and use the software regardless of their abilities.
So things like making sure a website can be navigated using a keyboard for people who can't use a mouse, or providing text descriptions for images for people who are blind or visually impaired.
Exactly. It's about creating a more inclusive and equitable digital world.
It sounds like user-centric testing is only going to become more important as software becomes more integrated into our lives.
It is. As software gets more complex and sophisticated, it's even more important to make sure it's easy to use, accessible to everyone, and provides a positive experience.
Okay, so we've talked about the what of software testing, but let's talk about the why. Our sources had a bunch of reasons why this is so important, and we've touched on some already.
Right. Cost effectiveness, security, user experience. But there are even broader reasons why software testing matters.
Okay, hit me with those big picture reasons. Why should we all care about this?
Well, first and foremost, it's about safety. Software is everywhere these days, in our cars, medical devices, everything. And bugs in those systems can have serious, even deadly consequences.
Right, like the Ariane 5 and the Therac 25. Those are some pretty stark examples.
They are, and they show that software testing isn't just about making things work, it's about making sure they work safely.
Right, protecting people from harm. And then there's the financial impact, which can be huge.
It can.
Software failures can mean lost money, damaged reputations, even lawsuits.
Absolutely. Think about that Bloomberg terminal crash or those Amazon sellers who lost tons of money.
When their products were listed for pennies.
Thorough testing helps prevent those kinds of mistakes.
And of course, there's the impact on us, the users.
Yeah.
We all want software that works well, is easy to use, and doesn't crash all the time.
Exactly. Software testing is all about quality, about making sure the technology we use every day is reliable, efficient, and, even enjoyable.
One of our sources mentioned customer satisfaction, which makes sense.
Absolutely. Happy customers are loyal customers.
Right. And that leads to positive reviews, recommendations, and ultimately more success for the company.
Exactly. Those positive experiences are what drive business success.
Now, one thing that surprised me is that our sources also talked about software testing being important for innovation.
I know, right? It seems counterintuitive.
But when you think about it, it makes sense. If you know you have a safety net, you're more likely to take risks and try new things.
Exactly. When you have a solid testing foundation, you have the confidence to experiment. You know that if something breaks, you can catch it and fix it quickly.
So it's like testing gives you the freedom to be more creative.
It does. Without that safety net, you're more likely to play it safe. Stick to what you know, which can really stifle innovation.
Our sources also talked about the importance of software testing for protecting a company's reputation.
Oh, absolutely. Especially these days, reputation is everything. One software failure can go viral in minutes.
And that can do some serious damage to a company's brand.
It can, and it can really erode customer trust.
It's like that saying, it takes years to build a reputation and seconds to ruin it.
Exactly. Good software testing helps companies protect that reputation by making sure their products are reliable, secure, and meet their users' expectations.
Okay, so we've established that software testing is crucial, but it can also be pretty complex. With all these different types, techniques, strategies,
It can be.
where can people go to learn more about all of this?
That's a great question. There are tons of resources online, tutorials, blog posts, online courses, certifications, all sorts of things.
Are there any websites or organizations you'd recommend?
The Ministry of Testing is a great place to start. They have a ton of information on everything testing related.
And what about specific testing tools? Are there any that stand out?
There are a lot of great tools out there, both commercial and open source. Selenium is popular for automated web testing, and Unit is widely used for Java unit testing. But the best tool really depends on the specific project and its needs.
So there's a whole ecosystem of software testing tools and resources.
There is, and it's always evolving as technology changes.
One thing that struck me from our research is that software testing is a field that's in high demand.
Absolutely. As long as we rely on software, we're going to need skilled testers. And as technology advances, that demand is only going to grow.
So if anyone's looking for a career that's challenging and rewarding, software testing is definitely worth checking out.
I agree. It's a field with a lot of variety, opportunities for growth.
Yeah.
And you get the satisfaction of knowing you're making a real difference. You're helping make technology better, safer, more accessible for everyone.
That's a great point. It really highlights the human impact of software testing. It's not just about code and algorithms, it's about people,
It is.
making sure technology serves us well and helps us live better lives.
Well said. And that brings us to another important aspect we need to talk about. The human element of software testing.
Okay, let's talk about that. What are some of the human factors that play a role?
Well, for starters, software testing is often a very collaborative process. Testers need to work closely with developers, product managers, all sorts of people to understand the software's requirements, identify potential risks, and come up with good testing strategies.
So it's not just sitting alone in a room clicking buttons and trying to break things.
No, not at all. It's very social and interactive. Testers need to be good communicators. They need to be able to explain technical things clearly and concisely, and they need to build good relationships with their colleagues.
Our sources also talked about the importance of curiosity and creativity in software testing.
Absolutely. The best software testers are naturally curious people. They want to know how things work, why they break, how to make them better. They're not afraid to ask questions, challenge assumptions, think outside the box.
So it's not just following a script. It's about thinking critically and coming up with new ways to test the software.
Exactly. And that creativity is how you find those subtle bugs that might otherwise be missed.
Our sources also highlighted the importance of attention to detail.
Oh, absolutely. Software testing is all about finding the little things, the things that other people might miss. Testers need to be able to spot inconsistencies, identify patterns, pay close attention to how the software behaves.
Like being a detective, right?
Yeah.
Looking for clues.
Exact.
And that attention to detail can make all the difference in catching those bugs before they cause big problems.
You can.
Another human element that came up was adaptability.
Right, and that makes sense. The world of software development is constantly changing. New technologies, new methods, new tools popping up all the time. Testers need to be able to keep up, learn new things, and embrace new approaches.
So it's not just about mastering a set of skills. It's about being a lifelong learner
It is.
and being open to change.
Exactly. That ability to adapt is essential for staying ahead of the curve.
Our sources also talked about the importance of teamwork and collaboration.
Of course, software testing is rarely a solo effort. Testers need to work well as part of a team, share knowledge, work together on plans, support each other.
So it's all about being a good team player.
It is. Strong teamwork is crucial for creating a good work environment.
It sounds like software testing requires a really interesting mix of technical and soft skills.
It does. It needs analytical thinking and interpersonal skills, attention to detail, adaptability, curiosity, a passion for quality.
It almost sounds like a way of thinking, not just a job.
I think you're right. It's about approaching things with a critical eye, questioning assumptions, striving for excellence. And those are valuable skills in any field, not just software testing.
Okay, we've covered a lot today. Different types and strategies of testing, user centricity, the human element, all of it. What are your final thoughts on all of this?
My final thought would be this. Software testing is essential for building a better digital world. It's about making sure the technology we rely on is reliable, safe, secure, and that it ultimately serves us well. And it's a field that's constantly changing and growing, which makes it so exciting.
I agree. I think we've given our listener a lot to think about. But before we wrap up, there's one more layer of complexity we need to address.
You mean the rise of AI and machine learning?
Exactly. How does AI changing the game for software testing?
That's a fascinating question, and it probably deserves its own deep dive.
It probably does.
But I think we've given everyone enough to consider for now.
I agree. We've covered the basics, explored why it's so important, looked at different types and techniques, and even touched on the human element. And we've hinted at the challenges and opportunities that AI brings.
Yeah, it's kind of wild to think how much AI is already woven into our lives. And it's only going to get more so, right?
It is, and that's why the future of software testing is so connected to, where AI goes.
Our sources definitely touched on that, hinting at how AI is already kind of changing the game.
Yeah, one of the biggest things is automation. AI tools can handle way more complex testing tasks now, which frees up human testers to focus on the more strategic stuff, the more creative parts of testing.
So it's not about replacing humans altogether. It's about making them better at what they do.
Exactly, like having a superpowered assistant. Takes care of the boring, repetitive tasks. So humans can focus on what they're good at. Intuition, creativity, problem solving, that kind of thing.
Our sources also talked about predictive analysis, which sounds pretty cool. It is. AI algorithms can look at tons of data and actually find patterns, predict potential problems. Like, imagine being able to spot bugs before they're even written into the code.
That's crazy. Almost like a crystal ball for software development.
In a way, yeah, AI can help us move from reacting to problems to preventing them in the first place.
Which would be huge, right? Lower costs, better quality, faster delivery times.
Exactly. And it's already starting to happen. AI-powered testing tools are getting smarter all the time. They're going to play a massive role in how we develop software in the future.
But AI also brings some new challenges, right?
It does. One of the big ones is making sure AI systems themselves are tested thoroughly and ethically. We're basically teaching machines to think, to learn, to make decisions. How do you test something that's constantly changing and learning?
That's a good question. It's like trying to hit a moving target.
Exactly. We need new approaches, new tools, new ways of thinking about testing to make sure these systems are safe, reliable, and unbiased.
Right, and our sources talked about that, the issue of bias in AI.
Yeah, AI systems are only as good as the data they learn from. If the data is biased, the AI will be biased too. And that can have real-world consequences, especially when AI is making decisions that affect people's lives.
Like, facial recognition system that's trained on mostly white faces. It might not be so good at recognizing people of color.
Exactly. And that can lead to all sorts of problems. Misidentification, discrimination, unfair treatment.
So testing for bias in AI, that's going to be a big deal for software testers going forward.
It is. We need to figure out how to detect and fix bias in these systems. And we need to have honest conversations about the ethics of AI and what role testing plays in making sure AI is used responsibly.
So the future of software testing isn't just about new tech. It's about some pretty deep ethical questions, too.
Absolutely. As AI gets more powerful, software testers are becoming even more important. They're not just checking for quality anymore. They're guardians of ethics, too.
That's a lot of responsibility.
It is.
But it also sounds really exciting, like being at the forefront of a new era, helping to shape how this technology impacts our lives.
It is, and this journey's just getting started. I think we're going to see a ton of innovation in the field of software testing in the years to come.
Well, on that note, I think we've given everyone a lot to chew on today. We've really explored the world of software testing, from the basics to its role in this AI-driven future.
We have. Hopefully, we've sparked some curiosity and inspired our listeners to learn even more about this fascinating field.
It's been a great deep dive. Can't wait for the next one.
Me too. Until then, keep exploring, keep questioning, and keep testing.
And to all our listeners out there, the next time you hit a software glitch, maybe you'll have a little more appreciation for the work that goes into preventing them. And if you're ever tearing your hair out over a badly designed app or website, remember, the folks doing user-centric testing are fighting the good fight. And hey, if you're intrigued by this whole world, maybe you'll even consider joining their ranks, helping to build a better, more reliable, more ethical digital world.
That's a great point. It's a field that needs talented people.
So until next time, happy testing, everyone.